everyone, welcome to episode 8 of Reconstructing Cave Story. So you'll notice I have a blank screen, and that's because there was an omission in episode 7 that I want to fix before we get started. So let's look at the slides. And in the last episode, I said sprites will no longer have control of STL surfaces, which means they won't create or delete. And I neglected to do that. So let's fix that in this episode before we really get started. So let's open up our Sprite class. And you can see in the destructor, I'm still calling STL free surface. So if we have multiple sprites using the same sprite sheet, one of the sprites gets destructed, it's going to free this surface, and then the other user of the sprite will be using an invalid sprite sheet, and that behavior is undefined. So let's go ahead and fix that in this episode. So let's first of all get rid of this destructor because we don't really need it anymore, and then we need to actually free the memory in our graphics class because that's what owns the memory now. So let's head over to our graphics class and look in the .h file, and you see this standard map is what actually owns the sprite sheets that get loaded in. So I'm going to make a type def to make typing a little bit easier for this standard map, and I'll just call it sprite map. And then in our destructor, before we free the screen, I'm just going to loop over the sprite map. So that's going to be sprite map iterator. Iter equals sprite sheets dot begin, while iter not equal to sprite sheets dot end, increment iter, and then we'll just free the value, which is held in second, because this iterator is a standard pair. All right, and that should clean that up. Let's make, just to make sure, use of undeclared identifier sprite sheets. Oh, that's because I forgot a semicolon here after our type def. So let's make again. This should be fine, and it looks good. Let's just make run just to be sure. And there we are, quotes walking. So let's look at the slides for this episode. So in this episode, we're going to be solving the problem of quote switching between sprites. So he's got his walk left sprite, his walk right sprite, and his standing left and standing right sprites. And I'll show you inside of our mychar.bitmap files. So here's his walking left sprite. Down here is his walking right sprite, exactly one tile below it. His standing sprite is going to just be this first animation, or this first frame of his walking cycle. So here's his stand left, and here's his stand right. And then later episodes, we'll get into him looking up or down. But for now, I'm just going to introduce this, so one piece at a time. So let's look at our implementation. And for our implementation, we're just going to have a standard map from state to sprites, where our state is going to need to know two things. One, are we walking? So are we going to be walking or are we going to be standing? Those are the two things that we need to know. Or that's one thing we need to know. And the other thing we need to know is which way are we facing, left or right. And are we walking can be pretty easily determined right now. It can be easily determined by our acceleration. Is our acceleration less than 0, then we're walking to the left. If our acceleration is greater than 0, then we're walking to the right. But are we facing left or right is a little bit more tricky, and that's because when we're done walking to the left, we'll still be facing left when we're standing, and we can't determine that from the acceleration or from motion or anything. So we need to add a little bit of state to our player in order to determine that. And we're going to use a standard map, and this means for our sprite state, which we'll implement as a C-style struct, kind of, with a constructor, I guess, means we need to implement operator less than, and that's one of the trickier parts of this episode, just because it's very logical, a lot of logic goes into it, and so that might be a tricky part of this episode. So let's go ahead and jump into it. So let's jump into our player class, player.h, and fill out our struct. So this is going to be struct sprite state, and it's going to have two pieces of data. It's going to have a motion type for either walking or standing, and it's going to have a horizontal facing for left or right. And these are both going to be enums, so I'll define these two. Enum motion type, standing or walking. And then enum horizontal facing is going to be left or right. I'll make a constructor, a default constructor. So it'll take in a motion type, and that's just going to default to standing. And horizontal facing is going to be defaulted to left. And we'll initialize our values. But really we should initialize motion type first. Motion type. Okay. And one more thing we need to do is we need to declare our operator less than to be a friend, since sprite state is a private nested class of player. So we'll say friend bool operator less than, and we'll say const sprite state a and const sprite state b. Let's compile. Okay, so now let's make our definition for our operator less than. So we'll jump to player CC, and we'll put this right below our namespace. It'll just be the same thing, the same declaration, except without friend. Operator less than const. I'm gonna copy and paste. I'm too lazy. Okay, that's better. But we need to scope these player, because they are nested. Sprite state is a nested class of player, and we'll just default to return false. Okay, now let's work out the logic of this. So the easiest way to think of this for me was if a.motion is equal to b.motion, then we need to compare if a.horizontal facing is equal to b.horizontal facing. So then we need to compare these, and this is pseudocode. Let's get rid of these ugliness. Okay, so if a.motion is equal to b.motion, then we need to compare a.horizontal facing to b.horizontal facing. But otherwise, if a.motion is not equal to b.motion, then we can just return a.motion is less than b.motion. We can't just return a.motion is less than b.motion, because if a.motion equals b.motion, we still need to compare this horizontal facing to see if it's less than or not. So I'm going to rewrite this a little bit, because we can just, start out by saying if they're not equal, then we return a.motion is less than b.motion. And we can, after that, check if a.horizontal facing is not equal to b.horizontal facing. Then we can just return A dot horizontal facing is less than B dot horizontal facing. And then, if they're both equal, that means this returns false because A dot motion equals B dot motion, and this returns false because A dot horizontal facing equals B dot horizontal facing. Then we know that the two things that we're comparing are equal, so therefore A is not less than B, so we return false. So that's that logic. If it's kind of tricky, I really encourage you guys to just pause and work through it yourself, because that's really the only way to understand logic, is just thinking it through yourself. Yeah, so let's make sure this compiles. And it doesn't because I called it motion, but I should have called it player CC. Motion type. Motion. So I'll just replace motion with motion type. And we'll try making again. And this time it works. So the next thing we're going to do is switch over to using a map. In our .h file, down here we have a scoped pointer to sprite, and instead this is going to be a standard map from a boost shared pointer. So we got to switch over to shared pointer since scoped pointer doesn't work, is not compatible with standard map or standard containers in general. So that's going to be a shared pointer of type sprite. And that's the value, but the key itself is going to be sprite state. And we'll call this sprites. So let's switch over to shared pointer instead of scoped pointer for our pound include, and get rid of this sprite, single sprite. And we can just kind of chase down the errors a little bit. So the first error is we don't have map, and that's a silly error because we should just include map. The next error is use of undeclared identifier sprites. So let's change all these sprites to be all these sprite singular to be sprites plural. So this first one is sprite.reset, and we'll, instead of doing that, say sprite sub, and we'll call it this. We'll define the default sprite state, which is standing left, and this is going to be equal to a scoped, a boost shared pointer that gets initialized, or of type sprite, that gets initialized with a new animated sprite. And we'll need another, nope, that looks good. So just anywhere we see sprite, I think we'll just use sprite sub default sprite state. So sprite sub default sprite state. And sprite state. And anywhere else. Let's compile. It compiles, so let's run it. Yep, there we go. So we're still using the sprite. Now, instead of using the default sprite state, let's make a method in player, a private method called get sprite state. And this will just get the player's current sprite state, and we'll use that instead of our default sprite state for when we're drawing and updating. So this will go in right after our last public method. And let's scope this in, player sprite state, player, no. Yes, player gets sprite state. And for now, we'll just return sprite state. But we're going to change this in a minute. And wherever we need to use it, we will. So not here, but inside of update and inside of draw, we'll need to use get sprite state instead of sprite state. Let's make sure that compiles still. Still good. Yeah. All right, so now we can kind of initialize all of our different sprites. Let's make a helper method for that too. We'll call it void initialize sprite sheets. Initialize sprites. And it'll take graphics because all the graphics need sprites in order to be initialized or created, or yeah. And this will go right above our get sprite state player. Okay, and we'll move this down into initialize sprite states. Initialize sprites, graphics. Oops. Move this down to initialize sprites, and make sure that compiles. Let's see how it looks. Still looks good. Still good. Good, good. Now let's actually make some sprites. So player CC. And this this animated sprite is of quote walking left, so let's correct this. This should be walking left because the default is standing left, but this animation is actually walking left. So let's make one for standing left. And this is just going to be a regular sprite instead of an animated sprite. So all we need to do is get rid of the extra information the animated sprite needs. And it's going to be the same frame, the very first frame, 0, 0, like I showed you at the beginning of this episode. And then we need to also make sprites or initialize sprites for the right. And the only difference here is we're going to be looking at the source rectangle one tile down. And this will also be right. Okay, so now that we've initialized our sprites, we can start using more than just the default sprite. And we're going to implement this in get sprite state. So we'll create a sprite state, and our walking is going to be based on acceleration x equals to 0.0f. If that's the case, then we're going to say we are standing. This is our motion type that we're working out right now. Otherwise, we'll say that we're walking. And this is just for now. Later when we add jumping, it'll be a little bit more complicated, but for now, this will be all that we need. And then for which direction we're facing, we're going to actually need to keep track of this inside of the player. So I'm going to say horizontal facing for now. Horizontal facing for now. And let's go ahead and implement this horizontal facing that I speak of. This can go just right below acceleration x, doesn't really matter, horizontal facing, and it's going to be called horizontal facing. And let's initialize it, of course, always initialize variables. And we can initialize it to be standing. Nope, that doesn't make sense. Let's initialize it to be left. That makes more sense. So, yeah, that should be fine. Yeah, let's try this out. He won't be able to face right yet because we don't actually ever change our horizontal facing, but I just want to make sure that this works as is. So let's make run. And he's standing. Now I press left, and oh, he does his walking animation. But he's always moving left, but when I'm standing, he's standing, and when I'm walking, he's walking. So this is really good. Let's go ahead and throw in our horizontal facing because that's really easy to do. Let's go to player CC, and when I say start moving left, all we're going to say is horizontal facing equals left. And if we start moving right, then horizontal facing equals right. And I think this is all we need. Let's look at how this turned out. So let's compile and run. He's looking to the left. I go left. Now I pressed right, and he's looking to the right, and he's standing right, standing left. Oh yeah, this is starting to look more like a game. Well, not quite a game. We still need a map and collisions and guns and okay, so it's starting to look like a simulation of a sprite walking left and right, but we're gonna get there. It's gonna be good. It's gonna be real good. So anyway, this is episode 8. Thanks for watching. Please feel free to ask questions. I might make a subreddit soon specifically for this, specifically for questions. But yeah, thanks for watching.